Hello friends, today I am going to do a session on Introduction to IMT 2020, that is 5G, in two parts, part 1 and part 2. So this is part 1. So the content of this presentation, part 1 presentation, will be standard making bodies, timelines and roadmap for 5G or IMT 2020, and the IMT 2020 vision given by ITU and the requirements, spectrum, and then 5G new radio. In the part 2, which is the second session, you can see the second video in the playlist, will cover 5G architecture, a high level 5G architecture, various use cases, and then deployment options of 5G, global launches, and then we'll talk about 5G devices, and finally what is the status of 5G in India. So let us talk about ITU, International Telecommunication Union. So ITU has three sectors: ITU-R, ITU-T and ITU-D. So ITU-R is for radio communication and it manages radio frequency, spectrum and satellite orbits, and it ensures interference-free operation of radio communication systems. ITU-T is for making standards, so they produce standards and defines tariff principles for international telecommunication services, and ITU-D is for development, which facilitates the creation, development and improvement of telecommunication and ICT. The other standard making body is 3GPP, Third Generation Partnership Project. So it covers cellular telecommunications technologies, including radio access, core network and service capabilities, which provide a complete system description for mobile telecommunications. So 3GPP has got three groups. We call it TSG, Technical Specification Groups, and they are radio access networks, that is RAN, services and system aspects, that is SA, and core network and terminals, that is CT. And they make specification for their area of work. Now let us talk about IMT. IMT stands for International Mobile Telecommunications. So ITU defines standards or requirement of every upcoming technology, and they call it IMT some version. For example, IMT 2000 is the name given by ITU for 3G services. So 3G is a marketing name given by OEMs, operators, etc. So IMT 2000, that is 3G, has got two approved technologies by ITU. One from 3GPP family, that is UMTS WCDMA. This is a GSM evolution, and the 3GPP2, which works on CDMA. So CDMA 1X EVDO revision A and EVDO revision B was accepted technology as 3G by ITU. So there were two technologies accepted by ITU as 3G. The next IMT version is IMT Advanced, which is marketed as 4G. It has also got two approved technology by ITU. One is from 3GPP family, that is LTE Advanced. Please notice it is not LTE. So LTE Advanced is the only approved technologies from GSM evolution side, and from WiMAX side it is 802.16M. M stands for mobility. Earlier version of WiMAX was 16E. So 16M version of WiMAX was accepted as one of the 4G candidate technology by ITU. Moving forward, so let us define IMT 2020 or 5G. So in terms of ITU definition, it is a name for the systems, components and related elements that support enhanced capabilities beyond those offered by IMT 2000, that is 3G, and IMT Advanced, that is 4G systems. And how 3GPP defines 5G? They define as a 3GPP system that meets the performance requirement for an IMT 2020 technology. This means that whatever ITU has defined as technical performance of IMT 2020 or 5G, 3GPP system will meet those performance requirements, and that they will call as 5G. So let us go through all the evolution of mobile telephony starting from 1G to now 5G in brief. So 1G was kind of analog voice which were deployed during 1980s, and the technology which they are using was AMPS, AMPS, NMT and TACS, TSCS. And it was just an analog voice, and if you move from one base station to other base station, your call will not continue. So it didn't had mobility kind of aspect in it. Now from 1980s to 1990s, the technology evolved to 2G. So in about 10 years, there was evolution in terms of deployment. 2G were started being deployed across the globe, and this was a digital voice. From an analog voice, we moved to digital voice in 19, and this was an efficient voice to reach billions, and this is the technology which is surviving even today. Many networks are still having 2G, and the technology which were offering this 2G, rather still offering, was DAMS, GSM and IS-95 version of CDMA. So the GSM was one of the major technology which is still surviving, and a lot of customers are still hooked on 2G technology. Then again, after almost 10 years from 90s to 2000, the 3G came, and 3G focus was mobile data. So focus shifts from a efficient voice to mobile data, that is wireless internet. And again, during the 3G, the technology which was there or still there was uh, from CDMA side, it was EVDO revision A and revision B. From GSM side, it was WCDMA and HSPA plus. So these were the two 3G technologies which was rolled out across the globe, and the GSM evolution, that is WCDMA, HSPA, 3G services are still continuing in many parts of the world. Rather, it is coexisting with other technologies, 2G and 4G, and in some cases even 5G. And then again after 10, so you see that every 10 years there is a evolution to the next generation of mobile telephony. So in 4G, it came around 2010. So here it was the focus on mobile broadband, from a mobile data to mobile broadband, and so high speed internet was made available, and then a lot of services, smartphone, etc. came into existence, and it is one of the a technology which is being deployed across the globe still, and becoming popular. In India, like all the private operators are offering 4G services, and they are having kind of a hybrid network of 4G and the lower version of the telephony, except Jio, which is pure greenfield deployment of 4G. So latecomers adopted 4G directly. And then again after 10 years, now it is 2020. So from 2010 to 2020, so again the telephony is mobile telephony is evolving to 5G, and 5G is supposed to be a future proof platform because it will support various kind of services. So the 5G has a new radio NR, it is called NR, and because of its flexibility to use wide range of spectrum and various kind of numerology, etc. So and overall architecture of 5G will support the services like autonomous car, uh, uh, automated industry, virtual reality, high speed broadband, enhanced mobile broadband, mission critical services like remote surgery, etc., etc., etc. So there is no limit. So it's a future proof, and we are going to discuss many of it in different sessions which we will have. So this is a graph which shows timeline for IMT development and its deployment. It is given by ITU in its one of the document. So if you look at this timeline from 1985 to 2000, so it is 15 years. So to develop IMT 2000, that is 3G, it took almost 15 years. Develop means development of specification by ITU, and parallel, of course, OEM starts working on that. And only after 15 years, that is in 2000, deployment of IMT 2000 started, and it's still going on. During 2000-2003, there was a vision created for IMT Advanced, that is 4G, and then it took almost 9 years to develop the specifications of IMT Advanced, and then finally deployment started around 2012. Some of the network, of course, will started prior to this, some trials and some small scale deployments, and this IMT Advanced is still going on. And parallelly, during 2012 to 2015, ITU created a vision document for IMT 2020, which is being marketed now as 5G. So the development here also, it took 5 years around, from 2015 to 2020. So in 5 years, that all the standards specifications were developed, and then the deployment started during 2020, and some network, of course, started getting deployed in 18 and in 19 also, but large scale deployment has started happening now, and few thousand of the network are deployed across the globe of 5G or IMT 2020. Again, if you look at these timelines, so this is also by ITU, one of their slide, and this was actually made in 2017, but I took this uh, graph all because this explains that although the GSM, the 2G service was kind of started deploying during the 90s, but it is still operating across the globe in many countries, many parts of the country, and this is one of the successful technology so far in mobile. And then the 3G, which kind of started during 2000, and it is still being deployed and still being used. Then parallelly, during 2010, IMT Advanced, that is 4G services started and still growing. Many countries or many operators are just starting deployment of 4G. So depending upon various countries, their capability to roll out technology is faster. And then the 5G has started being rolled out from majorly from 2020, and of course, as I said, there was certain deployment happening starting from 2018 itself. So now this is again a timeline. This is very important. This is timeline of working party 5D, uh, 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 which is working on IMT 2020 specifications for the terrestrial radio interfaces. So radio interface specification is being led by working party 5D, And these are the timelines. This is also taken from one of the ITU document which was published long back, perhaps in year 2015, and they has envisaged various timelines, and actually these timelines are actually met. So if you look at this, so they started with a technology trend report with their document M2320 during 2014, and then the second report was IMT feasibility above 6 gigahertz. So this is important because now the 5G is defined to work in wider band, even beyond 6 gigahertz and up to 100 gigahertz of the frequency. So this feasibility study report is in the document 2376 M.2376, and then during the 2015 the vision for IMT 2020 was published in the document M2083. This is an important document, everyone should read. And then during 2017, if you look, so technical performance requirement of IMT 2020 was published by ITU, which contains technical performance like the minimum peak data rate or minimum peak spectral efficiency or the latency or the reliability or the mobility. All those technical performance parameters are defined in the document M2410 by ITU, and they also release another document 2412 which contains evaluation criteria. For example, if 3GPP makes specifications complying to IMT 2020, then those performance of those specification or the standard or the technology decided by or given by 3GPP will be evaluated based on these criteria. And then there was another document which got published in 2017 is M2411, which gives uh, the template for submission of the candidate technology to ITU. So any standard making body including 3GPP can submit any candidate technology for its acceptance as 5G technology or IMT 2020 technology. That is the process which is followed by ITU. And then it was expected that now proposal will start coming by end of 17, and it will continue, and then it will be evaluated, consensus will be built, there will be a decision, and then finally IMT 2020 specifications will be frozen. In fact, it is already done. The IMT 2020 specifications are now frozen. So IMT 2020 will be in the various phases. So kind of the phase 1 specification of the IMT 2020 is frozen, and that is accepted by ITU. I'll discuss that in the later slides. So I discussed various document in the previous slide. So for convenience of all of you, so these are the important document listed here. So the ITU-T, so ITU-T has issued this document Y.3101. This is a requirement of IMT 2020 document. And then 2083 is a framework and overall objective of future development of IMT 2020 and beyond. And as I discussed, that 2410 is the minimum requirement for technical performance for IMT 2020, and 2411 is the evaluation criteria and submission template for a candidate technology complying to IMT 2020. So let us define IMT 2020 again. So IMT 2020 is a name for the systems, components and related elements that support enhanced capabilities beyond those offered by IMT 2000, that is 3G, and IMT Advanced, that is 4G systems. So IMT 2020 capability will be much enhanced compared to 3G and 4G. And the IMT 2020 will not only differentiate itself from the 4G network in terms of further evolution in radio performance, but also greatly increased end-to-end flexibility. This is important, end-to-end flexibility. And what does this mean? This means that IMT 2020 end-to-end flexibility will be achieved using various kind of technologies which are listed here, technologies and the requirement. The first is the network softwareization. So the network component today you have in 4G network MME or serving gateway or PDN gateway, and these are a specific hardware given by OEM today. So now the network element of 5G will be a piece of software which can run on any hardware. And then the software defined networking. So today when you network your 5G network or 4G network, there are a lot of configuration required at every router, and you have to manage. Even whenever you add a new node, a lot of configurations are required. So software defined networking will solve all these problems, and it will make easier to network your components. And then the next thing is network functions virtualization. So once uh, we have gone for network softwareizations, the next point is the network function virtualizations. If you are from IT field, you know that conventionally you used to have physical hardware on that servers. Physical hardware here I mean servers, that is compute, storage and networking, and then you used to deploy software on those physical hardware. And then came the concept of virtual machine, where uh, uh, the resources will be virtualized, and we create various virtual machine. On every virtual machines some software will run. And then came concept of container, wherein the software packages will run into a container and it will be managed by some software like Kubernetes or Docker Swarm. So containerization can happen using again some platform or software called Docker or any others, and you can manage that by so another software called Kubernetes. It was originally developed by Google and now then open sourced, and it is still open source. And then once you are able to virtualize a network function, instead of now a hardware or software, it is running on a virtual machines or as a container. So it enables now cloud computing. Now you can have a native cloud 5G architecture wherein all the network elements are deployed onto the cloud. So these all things will bring in deployment efficiency and flexibility. And another point is the minimized dependency on access network technology. So if you look at 5G, it will support all variety of access network. So in addition to the radio, it will support our other access network like the broadband or the cable network which gives broadband services. Those will also be connected to 5G core. So it will support whole lot of access networks. So the 5G system will be agnostic to the access network technologies, and it will have a minimum dependency on that. And 5G system is being designed so that the future emerging services can be incorporated into the 5G. And of course all these things will bring cost effective or cost efficient infrastructure, because once you start doing softwareization, network function virtualization, putting on cloud computing and start using SDN, so their infrastructure will become cost efficient. Now let us talk about various timelines of 3GPP and where we are in terms of specifications which is being made by 3GPP. So if you look at various releases by 3GPP, release 15 onwards is for 5G or IMT 2020, and from release 8 to release 15 it is for 4G, that is LTE, LTE Advanced or LTE Advanced Pro. So let us talk about release 15, which is 5G. So release 15 was actually developed by, or specifications were developed by 3GPP in three parts or three drops they call it: drop 1, drop 2 and drop 3. So if you talk about drop 1, it was an early drop which was released in December 2017, and mainly it focused on adding a new radio of 5G onto the 4G network itself, uh, so that even the NG RAN gets connected through EPC and you are able to uh, take advantage of high data rate or enhanced mobile broadband services. And then the main drop, that is drop 2, was released in June 18, and the final drop was drop 3 was released in March 19. And beyond that, now even the release 16 has been frozen and issued by 3GPP. So this is the status I have taken from 3GPP website as on 3rd July. If you go to the next slide, this is a timeline given by 3GPP on its website. You can just go to 3GPP timelines and see the timelines of various releases. So if you look at this, the release 16 was done in July this year, 2020. So today is 22nd August 2020. So in the month of July, 1 month back, more than 1 month back, release 16 was frozen. And then these are the timeline for various stages of release 16 and then release 18. So 5G will be deployed in various phases. So a lot of enhancement will continue happening from previous version to new version. Either the new enhancement or enhancement in the existing specification will continue happening. And the latest ITU update on their website was that 3GPP had submitted their specification to ITU to accept as a IMT 2020 technologies. So ITU-R formally approved this 3GPP 5G technologies, which is up to the narrow band Internet of Things NB-IoT, which is included in that as IMT 2020 5G standard. And when they decided this at ITU-R Working Party 5D. Please remember that I discussed that in the initial slide on to a pictorial graph, that Working Party 5D is making standards and so many documents. So in their 35th meeting of Working Party 5D, they accepted 3GPP 5G technology as one of the candidate technology for IMT 2020, and this was approved on 9th July online. Because of the pandemic, all meetings are happening online. So that was accepted on 9th July 2020. So now the 3GPP specifications are accepted as IMT 2020, a particular version up to narrowband IoT. So 3GPP is still continuing to enhance the specifications for release 16, 17, etc. And those will also be submitted to ITU for their acceptance in the upcoming meetings of Working Party 5D. Okay, this is a very important and iconic triangle diagram which talks about usage scenario of IMT 2020. So what would be the various uses, broad usage scenario of IMT 2020, that is 5G, and this is given in one of the ITU document, vision document, which was issued in 2015. So this triangle has got 3 vertex, and on every vertex one of the usage scenario is defined. So if you look at this particular top, it is enhanced mobile broadband, which is called EMBB. Small e, MBB is capital. Okay, so EMBB is enhanced mobile broadband, and here we talk about gigabit in a second. So if you look at the current data rates and the data rates which is defined in IMT 2020, so it is a huge difference. So it has to support enhanced mobile broadband, and because we have enhanced mobile broadband, will be supporting 3D video, ultra high density screens, and work and play in the cloud. Now let us move to this vertex on the bottom right side. This is for URLLC. So what is URLLC? So ultra reliable and low latency communications. And this is for services like self-driving car or autonomous car, which very reliable service and very low latency. So this is for that. In addition, other mission critical applications like remote surgery, a doctor operating from a remote, and then there could be industry automation like robotics and all will come into this. So there you require very ultra reliable and low latency kind of communications. And the third vertex is about MMTC. What is MMTC? MMTC is massive mobile type communications. So what does this mean? That there will be a lot of small devices, sensors, IoTs, Internet of Things. Uh, in a very narrow geographical area, there will be a large number of such devices. So a lot of connections will be required to be supported in 5G to support massive. That's why the name massive mobile type communications. So it will come handy in smart cities and other. So everywhere on the road, on the street, there will be a lot of IoT sensors operating in the vehicles, in various appliances. So that means the number of connections connecting these objects will be very high, and then our 5G network has to support such a huge dense connection. So of course, a smart home building, voice services, and all these services will come into picture. So now let us talk about various technical performance requirement of IMT 2020, so which is published by ITU in their document 2410 M.2410. You can download from ITU website or just type in the Google. It straight away goes to the ITU downlink page. So if you look at that particular document, ITU has defined various technical uh, performance requirement of IMT 2020 radio interface. So, and these are minimum. So these are the minimum requirement, and there is no bar if some specification making body is able to achieve more than this. So the peak data rate defined by ITU is 20 gigabit per second in downlink, and the peak data rate in uplink is defined as 10 gigabit per second, which is the minimum requirement. So minimum this has to be achieved. And so what is peak data rate? So peak data rate is defined as the peak data rate which can be achieved by allocating all the radio resources in a cell to one mobile in an error-free condition. Whatever data rate it is able to achieve will be called peak data rate in uplink and downlink. Similarly, the peak spectral efficiency, that means for every hertz of frequency how much bit rate we can achieve. So this is defined as 30 bit per second per hertz of the bandwidth in downlink and 15 bit per second per hertz in uplink. And this is again, it is the minimum requirement, and one is free to achieve more than this. And the next requirement is about user experienced data rate. So what is user experience data rate? Let us first talk about the rate itself. So it is 100 megabit per second in downlink and 50 megabit per second in uplink. And this is also defined as that if you have a coverage plotted, and then if you go to the fifth percentile of the coverage, that is towards the edge on the fifth percentile, so on that point this is the data rate one should be able to achieve. So what does this means? So barring those 5% people on the edge beyond those fifth percentile point, rest everyone will be able to get at least 100 Mbps of the data in downlink and 50 Mbps data on the uplink, and they will have experience of better than this speed, but this is the user experienced data rate at 5th percentile of the graph of the coverage of a cell. So that means 95% of the people will get at least this data rate. The next important for a enhanced mobile broadband and in a dense urban is the area traffic density, that in a per square meter how much data rate can be achieved. So in downlink it is defined as 10 megabit per second per square meter in an indoor hotspot environment. The next point or the next technical requirement is user plane latency. So user plane latency is related to the user traffic, how much time it takes for a particular thing to use. So the latency for user plane is defined as 4 millisecond in case of enhanced mobile broadband EMBB, and for ultra reliable low latency communication it is defined as 1 millisecond. Please mind these are minimum requirement, and uh, one can achieve better than this if some there are technologies or the standards available. And then comes the control plane latency. So control plane latency is defined in ITU document. Minimum requirement is defined as 20 millisecond, and they say that encouraged for making it 10 millisecond or better. So what is control plane latency? So when a mobile is in idle state and when it goes to active state and data flow starts, so the time from uh, idle to active, so there are a lot of signaling will happen between these two times. So the time required for a mobile to go from a idle state to active state is called control plane latency, and which is 20 millisecond. Okay, so now the next requirement is connection density, which is defined as 1 million devices per kilometer, and this is for mainly Internet of Things or sensors, which will be very large in number. So in a per square kilometer, maximum devices, rather minimum number of devices which should be supported is 1 million. And then of course the energy efficiency is one of the important technical performance requirement. So in a efficient data transmission in a loaded case, and then the low energy consumption when there is no data. So for 5G radio, when it is transmitting at full load, then it has to be efficient data transmission, and when there is no data transmission happening, then also it will consume some power, so it has to be very low energy consumption. And reliability, which will be mainly used for URLCC kind of application, ultra reliable low latency uh, communication. This is URLLC, not URLCC, so this is wrongly typed. So ultra reliable low latency communications. And then mobility. So here also mobility here has to achieve 500 kilometer per hour. This is not second, this is wrong. This is 500 kilometer per hour. And in different test environment, it has been defined as a different mobility, and this 500 kilometer per hour is for rural EMBB, that is rural deployment of enhanced mobile broadband, where you have to achieve 500 kilometer per hour, and it is mainly for the high speed trains. And for other scenario, if you look at indoor hotspot, it is defined as 10 kilometer per hour. For dense urban, it is 30 kilometer per hour, and then only in the rural it is 500 kilometer per hour. The technical performance requirement for mobility interruption time is 0 millisecond. That means there has to be no interruption during the mobility. When the UE is mobile, moving from one bus station to other bus station, so the interruption time allowed is 0 millisecond. And the bandwidth So if you look at 4G system, it can support maximum bandwidth of 20 megahertz. In 5G, it is defined that at least it has to support 100 megahertz of bandwidth and 1 gigahertz if the operation is in higher frequency bands, that is millimeter waves and all. This is again very important, very iconic uh, pictorial graph. This is also given by ITU. This is basically comparison of the capabilities, the radio capabilities from IMT advanced, that is 4G, to IMT 2020, that is 5G. And let us talk about each of the parameter one by one to understand clearly. And as I said, this is very important slide to understand. In nutshell, it gives all the capability of 5G and compares with 4G. So let us first talk about peak data rate. So as I said, that peak data rate for 5G is defined as 20 gigabit per second in downlink. And if you look at IMT advanced requirement of peak data rate, it was 1 gigabit per second in LTE advanced. So it is moving, it's a quantum jump from 1 Gbps to 20 Gbps. So 20 times increase in the peak data rate requirement in 5G. Similarly, if you look at the user experience data rate, I explained what is the user experience data rate. The data rate which you achieve at the 5th percentile of the coverage graph is called user experience data rate, and most of the people will get at least this data rate. So it is 100 megabit per second, and if you look at LTE advanced, it is defined as 10 megabit per second. So here also 10 times increase or 10 times jump in the user experience data rate. And the next is the spectrum efficiency. So spectrum efficiency, as I said, that how many bit per second you can achieve per hertz of the frequency, and for 5G we saw that it is 30 bit per second per hertz of a frequency. And if you compare with LTE advanced, so if it was 1x, now it is 3x. So the spectral efficiency is increasing 3 times in 5G compared to 4G, that is LTE advanced. And then area traffic capacities in terms of megabit per second per square meter. So in LTE advanced it was 0.1. Okay, let me tell you that the dark green part of the graph is for IMT 2020, and the inside part is IMT advanced. So it is comparing these two, how much difference it is bringing. So okay, let's come back to the area traffic capacity. So in IMT advanced it was 0.1 megabit per second per square meter. It is now 10. So here it's a 100 time increase in the area traffic capacity, because a lot of data will be used in a dense urban environment, and that's why this increase, and this will be achieved by the new radio capabilities, various capability which we'll discuss later in other session when we do a session on new radio. Now mobility. So if you look at the mobility in kilometer per hour, so it was 350 peak mobility which was getting supported in 4G was 350 kilometer per hour, and here in 5G it is defined to be supported as 500 kilometer per hour. Now let's go to the network efficiency, network energy efficiency. This is very important, because as far as 5G is concerned, there will be a lot of small cells. Number of base station will be very high. Number of devices like IoT, which will operate on a battery and will be in isolated mode, wherein there is no occasion to charge the battery and all, and once a IoT device along with the battery is installed, it will remain for 10-15 years, and it has to connect to the network without any power backup for next 10-15 years. So network energy efficiency is very important parameter, and that's why if it was 1x in 4G, it is 100x in 5G. So 100 times increase in the energy efficiency. And then of course the connection density is for IoT or the sensors. So how many devices it can support in a per square kilometer. So it was in 5G it is defined to be 1 million devices per square kilometer. The network has to support. It was 10 to the power 5. So that was about 1 lakh devices in a square. So here it is a 10 times increase. And then we talk about latency for mission critical services. So from 10 millisecond of the latency in IMT advanced, we are talking about moving to 1 millisecond latency. And then okay, I think we have covered all the points of the radio capability, and we have compared it with IMT advanced. Okay, let us move to the next slide. So this is also a very important diagram. This is also from one of the ITU document, and you'll find these two graphs being presented all across the world by ITU and the telecom professionals. So the same graph in a perspective of different importance of these key capabilities for different usage scenarios. So I discussed the 3 usage scenario as EMBB, URLLC and MMTC. So how these capabilities are required, or what is the importance of those capabilities. For example, if you look at enhanced broadband, which is given in this color, whatever color on your screen is coming, and you can just look at how it is defined. And if it is touching outer side, that means this is very high importance for EMBB. If it is on this area, then is medium. You can see these dotted circles, right? So the outermost is high importance, then medium, and then low. So if you look at enhanced mobile broadband, the peak data rate is of high importance. User experience data rate is for high importance for EMBB. Spectral efficiency is also of high importance. Mobility is also high importance. Area traffic capacity, very high importance for EMBB. And network energy efficiency is also very high efficiency for EMBB. So EMBB, to achieve EMBB, all these things are required, these capabilities are required. Okay, now let's talk about ultra reliable and low latency communication, which is defined in this color. So you can look at it is going like this. So if you look at what is the high importance requirement of URLC on the outer circle, if you see, it is touching latency and mobility. So latency and mobility are the two requirements of high reliable. So why mobility and latency? Because it is for vehicle, autonomous cars, so mobility comes into picture, and latency of course is a requirement. And other things, other things like connection density or spectral efficiency, etc., will be kind of requirement will be less. So it is touching here. So if you look at spectral efficiency, it is touching here. So it's a low requirement of spectral efficiency for URLLC. So that's how we can read this particular diagram. Now let us move to MMTC kind of services. So it is majorly, if you look at this is in blue color defined here. So it is touching a high importance area where there is a connection density. So the main requirement here is connection density will be very high. That is 1 million devices in a square kilometer. That's very important requirement. But it is touching suppose network efficiency here. So it is medium requirement. If it is area traffic capacity, so here it is requirement is low. So all these requirement of other things are low for MMTC. The only peak requirement which is touching is the connection density. So this is how you read this particular diagram. Okay, now let us talk about 5G new radio. So 5G radio is called new radio, and let us talk about various capability which new radio will have to support all these kind of usage scenario which we talked about. So the 5G NR will operate from a very low frequency band to very high frequency band, that is from zero point 0.4 gigahertz, that is 400 megahertz, to 100 gigahertz. So it will be operating on a very high range of frequency bands, and it will also operate in unlicensed band. So that is it says that including standalone operation in unlicensed bands. And when we say ultra wide bandwidth, so we say that the bandwidth used in 5G NR will also be high compared to 4G. In 4G it is 20 megahertz is the highest bandwidth which can be used, but here in 5G NR, as we discussed, that minimum requirement specified is 100 megahertz. So for a sub 6 gigahertz frequency band, up to 100 megahertz bandwidth will be used, and for more than 6 gigahertz band, above 6 gigahertz band and up to 100 gigahertz band, the bandwidth can be used up to 400 megahertz. And of course you have concept of carrier aggregation, and then a set of different numerologies will be used for optimal operation in different frequency ranges. So because of the frequency ranges, different frequency ranges in 5G NR, different numerology here. Numerology means is that of course here also will be using the OFDM waveform, and then in OFDM you have subcarriers, different subcarriers. So in 4G the subcarrier spacing which is used is 15 kilohertz, but in 5G you use not only 15 kilohertz but also 30 kilohertz, 60 kilohertz, 120 kilohertz and 240 kilohertz, and so different numerology in different frequency band, so different capability it gets. So we'll have a session on numerology when I discuss 5G radio in a separate session. And the other capability of 5G new radio is that it has to be forward compatible to accommodate new services in future. And it is also now the specifications, if you look at the specification of 5G new radio by 3GPP, so it has come out with the new channel coding. So LDPC for data channel and polar coding for control channel. This is low density polar coding, uh, which was in existence for a long time, but now uh, it has been decided to use because of its characteristic and the various huge scenario of new radio, and polar coding for control channels. And the new radio will have the native support for low latency and ultra reliability, and the RAN architecture of the new radio will be flexible and modular. So that is split front haul, split control and user plane function. We'll talk about this when we discuss core, that how control plane and user plane is getting completely separated in 5G network, so that it becomes flexible and modular. And then of course we have a concept of network slicing, end-to-end support for network slicing. Even the radio will be sliced, radio part will be sliced for different services. It is possible that you do that. Okay, so this diagram is by Erection on their website, which says that the 5G new radio will have three main characteristics, that is the flexible, forward compatible and ultra lean. And what we mean by flexible is that it will support diverse services and requirement, and it will also support wide range of frequency and deployment. We'll discuss in detail in the next slide. And ultra lean means it has to be very ultra lean in terms of various transmissions. So So it should be designed in a way that there is no transmission when there is no data is getting transmitted, or there is no need to transmit something. So ultra lean design, and forward compatible means it has to accommodate all the future evolution. The design should be in such a way, the 5G new radio design should be in such a way that it is forward compatible. Let us just take a few quick uh, examples or these requirements. So as I said that the five in terms of forward compatibility, since new radio has to support wide range of use cases, and some of the use cases are not yet defined, so it has to be forward compatible, and this parameter becomes very important. And how it is achieved? So forward compatibility in NR is achieved by self-contained and well-confined transmission. Please mind this word, self-contained and well-defined transmission. So what do we mean by self-containment? So self-containment means that data in a slot and a beam is decodable without dependency on other slots and the beams, right? So data will be complete within the slots and within the beam. And well-defined transmission refers to keeping transmission confined in frequency and time domains, so that in future we can allow or add, include new type of transmission in parallel with the legacy transmission, right? So this is forward compatibility of radio. And as I earlier said that ultra lean design means that minimize these always on transmissions. So there are certain always on transmission in the legacy 4G and other networks. So here we will change our 5G design that there should not be requirement of always on transmission, so that it becomes a ultra lean design. And for example, in 5G there are four reference signal, that is demodulation reference signal, phase tracking reference signal, sounding reference signal, and channel state information reference signals. So these signals are only transmitted when necessary, making new radio design ultra lean. So this is ultra lean design. Okay, so now let's quickly look at the 5G spectrum. So 5G spectrum, as I said, will be starting from 400 megahertz to 200 gigahertz, and there'll be a different usage scenario of different frequency band. For example, the frequency band which is below 1 gigahertz will be for a coverage. So such frequencies may be used for larger coverage, and then the frequencies in 1 to 6 gigahertz may be deployed as macro and small cells will be for capacity. And the other frequency, which is higher frequency in millimeter wave, maybe 28 gigahertz or 60 gigahertz, whatever frequency is decided to be used, will be used for very small cells, like cells working on electric pole in inside houses, and so on. So this will be for very high data rate requirement, hotspot, etc. It will support very high data rate. So these three kind of coverage can be achieved by different frequency band, deploying NR radio and different frequency bands. So the frequency band, where from where this frequency band will come. So as I said in the initial slide that ITU-R makes radio regulations, which is followed by all the member countries. I think there are 185 member countries of ITU. So normally they follow all the radio regulation made by ITU. And there is a concept of WRC, the World Radio Conference, which happens every 4 years. So WRC 19, which happened in 28th October to 22nd November 2019, they identified certain additional bands to enable 5G deployment. So if you look at earlier allocation of frequency, so earlier it was just 1.9 gigahertz in total for IMT, International Mobile Telecommunications. So all these frequency bands are allocated for IMT, not for a specific technology, but for the IMT. So the additional band, which is this in red color shown here, was given for IMT, and then this will enable 5G deployment. So all those millimeter wave frequencies, of course, if you theoretically see, millimeter starts when you have frequency 30 gigahertz, but generally even 28 gigahertz is being called as millimeter. So practically, so these are the frequency band in 24 gigahertz, here in 37 to 43 gigahertz, 45 to 47 gigahertz, and so on. So these were the bands given by, approved by ITU in WRC 19 for IMT. So in total, now including this 1.9 gigahertz, has become 17.25 gigahertz of spectrum for IMT, which is given by, so different country. So this frequency may not be free in different countries, they may be using it, but this is what has been and why this allocation from ITU comes, that worldwide, if you use the same frequency for same purpose, you can interwork, and the chances of interference and all will be avoided, right? Now let's talk about 3GPP. So 3GPP in its specifications have defined two frequency ranges for 5G. So once ITU has given, then the 3GPP has also defined, and that is called frequency range 1 FR1 and frequency range 2 FR2. So frequency range 1 is the sub 6 gigahertz or up to 6 gigahertz frequency, starting from 450 megahertz to 6 gigahertz. And FR2 is frequency range 2, which starts from 24 gigahertz up to 52 gigahertz. So these are the two frequency band by 3GPP. And now this is the last slide. We will talk about other aspect of 5G new radio. So as I said that there is FR1 and FR2. FR1 is the frequency band below 6 gigahertz or up to 6 gigahertz, and this is beyond 6 gigahertz and up to 100 gigahertz. So bandwidth option, as I said that in LTE the maximum bandwidth is 20 megahertz, starting from perhaps 1.4 megahertz. So in 5G it will support in FR1 band 5 megahertz, 10 megahertz, 15 megahertz, 20 megahertz, 25 megahertz, 30 megahertz, 40 megahertz, 50 megahertz, 60, 70, 80, 90, and up to 100 megahertz in FR1. And if you go to the frequency band FR2, which is beyond 6 gigahertz, the bandwidth will be 50 megahertz, 100 megahertz, 200 megahertz, 400 megahertz. So up to 400 megahertz the bandwidth will go in the FR2 band. And what will be the sub-carrier spacing? I said that the OFDM waveform, which was also used in 4G, will be used in 5G. So what is the sub-carrier spacing which can be used? In 4G it was 15 kilohertz, but in 5G we use different numerology, means that different sub-carrier spacing. So in FR1 we'll be using 15 kilohertz, 30 kilohertz and 60 kilohertz, and in FR2 we will be using 60 kilohertz, 120 kilohertz and 240 kilohertz. So 60 kilohertz can be used in FR1 and FR2 both. But if you use in FR2, the concept of extended cyclic prefix comes, which we'll discuss. And maximum number of subcarrier you can have 3300 with FFT 4096. And the carrier aggregation up to 16 carrier can be aggregated. So if you just calculate, suppose if you have 400 megahertz bandwidth and you have in FR2 and you have 16 carriers in FR2 itself, so 16 into 400 megahertz, so it becomes 6.4 gigahertz. So your effective bandwidth theoretically can go up to the 6.4 gigahertz in 5G new radio. And the modulation scheme is, again, it is similar or same, which will be all QPSK, BPSK and QAM for different thing. For uplink and downlink it will be used. And let us talk about the radio frame. So radio frame length in 4G was 10 millisecond. Here also it is 10 millisecond. Subframe duration in In 4G it was 1 millisecond, here it is 1 millisecond, and the duplex mode can be FTD, TDD in FR1 band, and FR2 it is recommended the TDD, right? And the multiple access scheme, here it will be use CP OFDM, cyclic prefix OFDM, and in downlink, and in uplink it can be CP OFDM and DFT OFDM. And of course the MIMO schema will be used, so we will have a separate session on MIMO. So maximum of 2 code words mapped to maximum of 8 layers in downlink, and to maximum of 4 in uplink will be used in the new radio. So this was the last slide of part 1, 5G introduction part 1, and then the rest of the items we will discuss in part 2 video. So thank you everyone, and in case you have questions you can type in the comment box below, and you can also connect me through Twitter or Gmail or other IDs or the mobile which is here. So thank you everyone.